Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Now we are going to study in this session how to draw a cam profile when the roller follower having a motion of uniform velocity, uniform acceleration and retardation with offset. So here we are going to draw a cam profile by taking the example of a problem. Here a cam is rotating in clockwise direction at a uniform speed of 1000 revolutions per minute. He is required to give a roller follower. The motion is defined. The follower to move outwards, that is outward stroke, is 50 millimeters during 120 degrees of cam rotation. And follower or dwell next of 60 degree of cam rotation. The follower to return its starting position during the next 90 degree of cam rotation. Follower dwells after the rest of the cam. So the minimum radius of the cam is 50 millimeter and the diameter of the roller is 10 millimeter. The line of stroke of the follower is offset by 20 millimeter from the axis of the camshaft. If the displacement of the follower takes place with uniform and equal acceleration and retardation on both the outward and return strokes, draw profile of the cam. So here we are going to take the profile of a cam roller follower. Okay, roller follower, and it is very important that it is offset by 20 millimeter, and the diameter of it is 50 millimeter is outstroke. So here 50 millimeter is the lift of the follower. It is the lift of the follower or stroke of the follower, and theta outward stroke equal to 120 degree, theta dwell after the outward stroke, that equal to 60 degrees. Next, theta return stroke is 90 degree and remaining angle. So 120 plus 60, 180 plus 90, 270. So for 360, how much it is remaining? 90 degrees is the remaining dwell. Next, the minimum radius of the cam, that is 50 millimeter, and diameter of the roller is 10 millimeter. The line of stroke of the follower is offset by 20 millimeter. So we have to take a scale, and we have to draw the displacement diagram. The displacement diagram is here. The motion of the follower is uniform acceleration and retardation, both the strokes. So let us draw the displacement diagram. Theta O 120 degree, theta dwell during outward stroke is 90 degrees, 60, 90, 90. Return is 90 and dwell during return is 90 degrees. So what is the lift of stroke of the follower? That is 50 millimeter. This 50 millimeter related to y-axis, and this rotation of the cam related to x-axis. So for drawing the displacement diagram, take a scale. Scale for x-axis equal to scale for x-axis, that is consider 20 degrees equal to 1 centimeter. 20 degrees equal to 1 centimeter, then theta O becomes how much? 6 centimeters. Theta OD becomes 3 centimeters after converting the scale. Theta return, it is 4.5 centimeters. Theta return D, that is 4.5 centimeters. With these dimensions, we have to draw the displacement diagram, both x-axis and y-axis. So draw the displacement diagram. I'm going to show here, that is x. Take approximate the position, that is 6 centimeters, that is theta O. Next, that is theta OD. The theta OD is 3 centimeters. The angle of theta OD is 60 degree. And the theta return, that is 4.5 centimeters, and remaining is also theta return dwell. So close this displacement diagram. Here, this is the circle. Complete the Now draw the vertical lines. Now divide this outstroke and return stroke with even number of parts. So even number of parts, we can take it as a 6 or 8 or 12. So we can consider as a 8. So this is the displacement diagram, it seems. Now what is the first step? This is 120 degree horizontal and 50 millimeter vertical. This is 120 degrees and it is 50 millimeters. The first step. The next step is, what is the next step? Next step is divide this outstroke angle into even number of parts. Here complete that AS. This is that A. Okay, AJ. Complete this into 8 even number of parts. That is 6 divided into 8 parts. Okay, 8 even number, 8 equal parts. So then after that, join vertical lines. Join vertical lines. Similarly, the outstroke also should be divided into 8 equal number of parts. So we consider the outstroke how much here, how many 4.5 centimeters and equally divided 45 millimeters into equal 8 parts. Then join with vertical lines. Then after dividing this, what to do? Make a center line. The center line is the fourth here. This side 1, 2, 3, 4, 1, 2, 3, 4. So any center line you consider. Actually they considered here how many parts? 1, 2, 3, 4. Yeah, equal divisions. So center, that is center part is the fourth number. That fourth number you divide into equal height. This 50 millimeter again should be divided into equal number of parts. Then join these corners of from A to those divided parts. The parts are divided here A, B, C, D, E, F, G, H. These are all equal divisions. So what to do? Sum of the parts, the center line A to J, there is a midpoint passing through that, but remaining bottom lines A to capital A to small a, join the line. Similarly, capital A to B, capital A to C, and capital A to D. Similarly, from bottom to top, it is like J to E, J to F, J to G, and J to H. Similarly, outstroke also we have to divide the outstroke part, that is G, F dash. Similarly, outstroke also divide into equal number of parts. Now these lines are dividing the vertical lines. Suppose AA is dividing the 1 at this point. This is the point A. A is divided, this is the point A, and A to B dividing the second line, and A to C dividing the third line at this, that third line, and A to D, this is next from bottom to top. JE is dividing, that is intersecting with 5, JF at 6, JG at this point, 7th line. So all join all these lines with a smooth curve. That curve gives the parabolic path. Similarly, outstroke also you divide those intersecting points, and 8A is dividing which line? 7th line. 8B, B dash, that's 6. 8C, 5. From bottom, from top, KG dividing the third line, KG dividing the first line, next KF dash, second, KG dash, and it is the D. Join all these points with a smooth curve. So this curve indicates the path of a follower under the cam rotation during outstroke, dwell and return strokes and remaining dwell positions. So this is the curve. The path what is the displacement curve of the follower? The displacement curve of a follower is the curve between the angle of rotation of the cam with respect to the motion of the follower. The total during outstroke, the maximum lift of the follower is 50 millimeters, and during return stroke it comes back again 50 millimeters. So this 50 millimeters once it goes rising, outstroke and return stroke happens in one revolution of the cam. The one revolution of the cam equal to how many degrees? 360 degrees. The sum of outstroke, dwell, return stroke and remaining dwell during return stroke, the summation of all those angles equal to one revolution of the cam, that is equal to 360 degrees. Now here 120 degree equal to outstroke angle and 60 degree dwell during outstroke, 90 degrees return stroke angle, dwell during return stroke, that is 90 degrees. So this is the path. What is the first step? Take a scale. Second step, draw the x-axis. Third step, draw the y-axis. And next step is draw the vertical, divide the outstroke and return stroke with even number of parts. Here it is divided 8 number of parts, and draw a vertical lines. After next step, take a center line, divide into equal, that is even number of parts, 8 number of parts, and join the inclined lines with the corners from A to J to the center lines, to the center line of division line, divided lines. The intersection of these inclined lines with the vertical lines mark the points and draw the curve. That's it. The displacement diagram will be observed, will be obtained. Next, this is the displacement diagram. After the displacement diagram, we have to go for follower. Now it is an offset case. What is the offset? Offset by 20 millimeters and the diameter offset by 20 millimeters. The diameter of the roller, yes, and the diameter of the roller is 10 millimeters. So what to do? What is the next step? The next step is, what is the minimum base circle radius? The minimum base circle radius is, what is the minimum base circle radius? Yes, the minimum radius of the cam is 50 millimeters. Alright, roller 10 millimeters, offset by 20. Now, the minimum radius of the cam is 50 millimeters. Roller follower, that is 10 millimeters radius or diameter, is the diameter of the roller. Yes, is the diameter of the roller equal to 10 millimeters. Offset by, what is the offset is? Offset equal to 20 millimeters. Now, how to start? Draw the radius of the cam, minimum radius of the cam. Next, draw the offset circle. After drawing the offset circle, draw a vertical line, axis line, by touching the offset circle. This is the point, and whatever next point, what is the 10 millimeter diameter of the roller is 10 millimeter. Take the radius 5 millimeters with this axis. Draw another circle. That is the prime circle. This is the center of the roller. The center of the roller and the diameter of the roller is 10 millimeters. Join the center of offset circle with the center of the roller. From this is the reference line. From this divide, draw a outstroke angle of inclination, that is 120 degrees. Next, this is 120 degrees. Dwell 60 degree. Return stroke 90 degree. Remaining is dwell. So this is theta O, that is outstroke. theta OD, and it is theta written, and it is theta written during dwell. Now divide the prime circle into 8 number of parts. Divide this prime circle into 8 number of parts. Taking the dark color, so that 8 number of parts. This is point 1, 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3, 4, 5, 6, 7, and it is 8. The next return stroke also, return stroke of prime circle, return stroke angle also divided into 8 number of parts. So now very important, this is 8, 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, and it is 8 dash. Very important that now we have to draw a tangential lines to the offset circle passing through the divided points of a prime circle. Now now draw the tangential lines. You keep, it should be tangential. Okay. I am drawing freehand. You have to follow. We have to follow scale geometric instruments. Similarly, these are the tangential lines. On the tangential lines, you mark the displacement of the follower with the angle of rotation. 0 to 1, you mark it, this distance. 1 to, what is the 0? This is 1 to point B. This is the point B. This is the distance 1 to B, mark it 1 to B. This is the point B. Next, take a distance from 2 to this distance, 2 to C. This is the 2 and it may be C. Next, 3 to D. 3 line approximately D. Not approximately, mark directly. Next, 4 to E. 4 line and it is E. 5 to this point. 5 to F. It is F. 6 to G. 7 to H. 8 to J. 6 to approximately it will be here. This is F, G, H, J. Similarly, an outstroke also you have to follow. 0 to K distance. This is 0 dash approximately K. Next, 1 dash to M. Little bit less. This is 1 dash to M. 2 dash to 1 dash to L. 2 dash to M. 1 dash to L. 2 dash to M. 3 dash to N. 3 dash to N. 4 dash to P. 5 dash to Q. Like that you complete the portion. Now these are the centers of a roller. Now we have to draw a circle of the roller circle with the diameter of 10 millimeter. That is the radius. The path traced out the contacting points, that is the surface of the rollers, that gives the that gives the profile of a cam. So this is the profile of a cam. You have to use geometric instruments, then the profile of a cam looks like that. This is the manner after joining the points. So the diameter of the roller is 10 millimeters. So these are the points. First step, draw a base circle, minimum radius of the cam. Second step, same center, draw a offset circle. Third step, draw the vertical line. So by touching the offset circle of circumference of the offset circle, this is the third step. After that, join the contacting of the roller with the center of the offset circle. That line is the reference line. From there you divide the circumference of the prime circle. That the prime circle is the circle of the circle from the offset circle center to the center of the roller. That circle is the prime circle. Divide the circumference of the prime circle into outstroke, angle of rotation of the outstroke, that is 120 degrees, next is 60 degrees, 90 degrees and 90 degrees. Then divide the prime circle into equal number of parts and draw the tangential lines passing through the offset circle of the cam through the prime circle divisions. Then on the prime circle divisions lines, tangential lines, mark the displacement. So the displacement markings are the centers of the roller. So where you have to draw the rollers. The diameter of the roller is 10 millimeters. Okay, after drawing the rollers, these are the rollers A, B, C, D, E. So if we understand here, in the displacement diagram, at a particular angle of rotation, this 120 degrees is divided into 8 parts, 120 by 8. Okay, that is approximately 15 degrees each. Okay, 15 into 8, 120 degrees. So for every 15 degree rotation of the cam, first initial 15 degree, the roller is at, where is that? The roller is at this point. Then next 15 degrees, that means total here, the roller. Next, this is the roller centers. These are the centers of the rollers. For 120 degree rotation of the cam, the follower lifted to 50 millimeters. Now dwell, next point, it is the next roller, next degree, 90 degrees of rotation, then again 8 parts. Then for every, this is the roller rotations, these are the markings are there now. These markings indicates the positions of the rollers. Then the roller remains the same, constant position. So these are the roller points and the displacement. That's why these rollers markings we made here centers and draw the same diameter of the rollers, that is 10 millimeter. So when the roller is in contact with the cam, it is the point contact. So that's why we have to draw the circumferences by touching the smooth curve, by touching the circumferences of all the rollers. That smooth curve gives the profile of the cam or shape of the cam. So this is also called a design of a cam. So how to design the cam? That is nothing but based on the input parameters. The input parameters are lift of the follower and also angles of rotations of the cam during outstroke, return stroke and dwell periods, dwell angles. Now you can verify this profile of a cam with respect to the displacement diagram. For 120 degree rotation, the maximum lift of the follower takes place, that is 50 millimeters. You can see here, it is 120 degrees. This zone is 120 degrees. Yes, this is the portion. By trying tangential lines, from here it became, this is 120 degrees of rotation. For this 120 degrees, the lift of the follower is 50 millimeters. When it rotates, the lift of the follower takes place. 50 millimeter maximum lift takes place. Then 90 degrees, after 60 degrees, it remains the same. and remaining 90 degrees it comes back, so it goes down. So follower lifts 120 degrees, stays 60 degrees of cam rotation. That means it is the remaining radius, constant radius here. How much it is? 50 millimeters. Understand? Now the distance from the here circumference circle to here, this distance y to k and x to j both are same. Next, remaining 90 degrees, what is the remaining? Return stroke takes place. That means comes down. And one more 90 degrees here, this is the zone. 90 degrees is remains constant. That's why this is the follower shape of the this is the shape of a cam. So this is the case study when the follower rotates, okay, when the follower is a roller follower and the motion of the follower is uniform acceleration and retardation for return stroke, outstroke and return strokes. So here very important is that the shape of the cam is dependent on the displacement of the follower and also angle of dwell, angles of outstroke, angles of return stroke and return dwell period during return strokes. These are the angles, and also the motion, the shape of the cam is also dependent upon whether the follower is under either uniform acceleration or retardation or simple harmonic motion or uniform velocity motion. So it depends upon the motion of the follower, it depends upon the type of the follower, it depends upon the angle of rotation of the cam during dwell, outstroke, return stroke, period time, angles of rotation of the cam. So these are the things. But the lift of the follower designates is the size of the cam. The size of the cam is dependent upon, again, the size of the cam is dependent upon the lift of the follower. If the lift of the follower is small, the size of the cam is small. The lift of the follower is large enough, then the size of the cam is also large enough. So it depends upon those parameters. The design of the cam is dependent upon lift of the follower, angle of rotation of during dwell, outstroke and return strokes. So these are the important points one has to remember. One more thing, here it is mentioned clearly that it is rotating clockwise direction. That's why the follower is moving in anti-clockwise to get the shape. So most of the cases, 99%, unless and until it is mentioned, we have to follow. Otherwise, by assumption, you consider that it is under clockwise rotation of the cam. The rotation of the cam is under clockwise. Okay, that is what we follow here. So with this we completed the cam profile, how to draw the cam profile when the follower is under uniform velocity and uniform acceleration and retardation with outstroke angle of 120 degrees, next to outstroke is 60 degrees and return stroke is 90 degree and after the remaining is 90 degrees of rotation of the dwell, and lift of the follower is 50 millimeters and the diameter of the roller is 10 millimeters and the minimum radius of the cam is 50 millimeters and offset by 20 millimeters. That's why this is the problem of offset roller follower following with uniform acceleration and retardation offset by 20 millimeters. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.